This is Intro to Triangles, Day 2 notes. In the warm-up, numbers 1 and 2 ask you to classify the triangle. In number 1, all three angles have the same measure, which makes this an equiangular triangle. For number 2, the side lengths of each of this triangle, all three are different, which makes this a scalene triangle. Number 3 says triangle PQR. Angle P is congruent to angle R, and the measure of angle Q is twice the measure of angle R. Wants us to find the measure of each angle. So we know that in a triangle we have 180 degrees, and we have that P and R are the same, so those will both be represented by X, and Q is twice the measure of R, which will be 2X. So we set it up X plus 2X equals 180, 4X equals 180, and X is going to equal 45. So therefore, the measure of angle P and the measure of angle R are both going to be 45, and Q is going to be 90. For number 4, we know that this box down here means 90 degrees, which means that 2X and 4X have to combine to equal 90 degrees also. So we set this one up, we do 2X plus 4X is equal to 90. Combine like terms to get 6X equals 90, and X is going to equal 15. For number 5, we know that this outside angle 3x minus 22 is going to be equal to these two other inside angles added together. So to set up number 5, 3x minus 22 equals x plus 80. If we do some moving around, we get 2x equals 102, and x should equal 51. Now on to the notes. Today we're going to talk about isosceles and equilateral triangles. First, a couple definitions about isosceles triangles. The legs are the congruent sides of an isosceles triangle, and we'll talk more about that in a minute. The vertex angle is the angles formed by the legs of an isosceles triangle. The side that is not a leg is called the base, and the base angles are the angles formed by the base and the legs. And again, all this we'll talk about in just a second. In this picture, we're talking about the base angles theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent. So in this picture, we notice that these two sides are congruent. If we know those two sides are congruent, we know that their base angles down here are also going to be congruent. So if the two sides are congruent, the two base angles are congruent. And the same is true if the two base angles are congruent, then we know that the legs are going to be congruent. Moving down to equilateral triangle. The corollary to the base angles theorem is if a triangle is equilateral, which means all the sides are the same, then it is also going to be equiangular. So if all the sides are the same, all the angles are also going to be the same. The same holds true if all the angles are the same. If it's an equiangular triangle, it's also going to be equilateral, which is the corollary to the converse of base angles theorem. All right, keeping these ideas in mind, let's do some examples. Number 1. It tells us that these two angles down here are both 60 degrees. Okay, so if these are our base angles, if they're the same, then the two legs also have to be the same. So if this side is 16, then x is also going to be 16. For number 2, we have our base angles congruent down here again. Okay, so if these are our base angles, 5x plus 5 and 35 are going to be our legs. So if the base angles are congruent, then the legs are congruent. So 5x plus 5 is going to equal 35. Solve for x and you get x equals 6. Down here at the bottom, for number 3, find the value of x and y. It tells us that the legs are congruent. When we know the legs are congruent, we know the two base angles are congruent. So x and 9y, although they have different variables, can be substituted in for one another. We know that this is a 90-degree angle, so the rest of the triangle has to equal 90 degrees. So to set it up, we do x plus 9y equals 90, And like I just said, we can substitute x in for 9y because they're the same. So x plus x equals 90, 2x equals 90, and therefore x equals 45. So now that we know the base angles are 45, we can find y by setting 9y equal to 45, solving for y and getting y equals 5. Number 4 is a little complicated. We'll go over this one in class. For number 5, again we have the legs are congruent, so we know that the base angles are congruent. So for number 5, we set this up. 13x minus 2 equals 7x plus 19. We combine to get 6x equals 21 and x equals 3.5. So now that we know that x equals 3.5, we've got to plug it back in to find the measures of the base angles. The base angles come out to be 43.5, so when you add them together they're equal to 87, which means that this top angle up here has to be 93, because 93 and 87 equal 180. So 11y minus 6 equals 93, 11y equals 99, and y equals 9. For number 6, again we have the legs are congruent here, so we know that the two base angles are going to be the same. So x minus 2 and this angle over here can also be x minus 2. So to find x, we add the three angles together and set it equal to 180. So x minus 2 plus x minus 2 plus 4x plus 10 equals 180. Combine like terms to get 6x plus 6 equals 180. 6x equals 174, and x is 29. Now that we know that x is 29, we can plug it back in. I chose to do it over here next to the 3y because 3y and x minus 2 are a linear pair. So if x minus 2 and x is 29, we get that angle to be 27 degrees, which means that the angle up here is 153. So 3y equals 153, we divide by 3 and we get y equals 51. For number 7, it's looking for the perimeter of the triangle. Again, we have base angles are congruent in this triangle, so we know that the legs are going to be congruent. So we set 7x minus 13 equal to x plus 29. We solve for x, we get 6x equals 42, and x is equal to 7. Once we have x equals 7, we got to plug it back in to find the measures of each side. 7 times 7 minus 13 is 36. 7 plus 29 is 36. 3 times 7 plus 5 is 26. You add them all together and you get the perimeter is 98 inches. Same thing for number 8. We have base angles are congruent, so the legs are going to be congruent. 4x plus 3 is equal to 8x minus 15. We solve for x, we get 4x equals 18. We divide by 4 and we get x is equal to 4.5. Again, we have to plug x back in once we find it. 4 times 4.5 plus 3 is going to be 21. 8 times 4.5 minus 15 is 21. And 5 times 4.5 plus 8 is equal to 30.5. Again, we add all three sides together and we get the perimeter to be 72.5 meters. And I want you to try 9 through 12 on your own to see if you can figure out whether the triangles will always, sometimes, or never be whichever one.